This is the solution video to the puzzle The Belly Button. It was an intermediate puzzle published April 18th of 2024. And it featured a quarter circle together with a right triangle. And a line segment was drawn from the right angle towards the center of the quarter circle. And the question was to prove that the intersection point of this line segment with the circle is actually the incenter of the green right triangle. And to show that visually, if I look, you see here that indeed it's very nice that it appears to be the incenter. But of course we have to prove that. Well, for that we need to prove that actually the line through the incenter towards the vertices bisects the angle. So for instance over here we have to show that this is a 45 degree and this is 45 degree, and we have to show that for the other two well, actually for one other angle, because if we have shown it for two, then it is obvious that for the third it is also valid. Okay, and I'm going to take the approach which was among others taken by ex-follower Ohm, and what he saw was that because we have here a right angle, because it's a quarter circle, so in here we have a right angle and we have a right angle over here, so these 4 points are cyclic. The opposing angles add up to exactly 180, so we can draw a circle through those points, and this point then is also on that circle. And why is that handy? Because we know that here we have 45 degrees. Let's state it, 45 degrees over here. And because we know that that angle is the same as that angle, we know that also here there is a 45 degree angle. And we're using the circle, and we're using the fact that the angle from one chord is constant along the circle. So in a similar fashion, here we have also 45 degree, and that means that this is also 45 degree. So we have immediately established that indeed this line segment bisects the right angle over here. So we're halfway. Now we're gonna look at this line, and we're gonna prove that it also bisects this angle. Let's see. Well, first we're gonna use the fact. Let's see. Now, first we're gonna use the fact that again from the large circle, let's call the angle over here 2 alpha, and it will become apparent why I use 2 over here. Then we know from because this chord gives that angle, then we know that this total angle is also 2 alpha. We're using again the larger circle, so we know that over here we also have 2 alpha. So that's the total angle over there. But now we're going to use the quarter circle. Here we have a chord, an arc, and it goes to this point of the quarter circle, and here it goes to the center, and we're using the inscribed angle theorem, which states that the angle at the center is exactly twice the angle at the circle. So at the center we know it is 2 alpha, and therefore we know that this angle, this smaller angle, is half that, so it is alpha. So here we have alpha. That's that angle. But we have previously established that the total is 2 alpha, so therefore we know that again this angle is also alpha, and therefore the angles are the same. So we have proven that this angle is bisected by the line to the red vertex, and this angle is also bisected to the line to the red point. So this means that the red point actually is the incenter of the green right triangle. And that completes the proof of the puzzle, the belly button.